Hello, this is Abdulla Taymour, group members with Ali Nadhaif, Benjamin Thong, and Ruth Delgado. We will be explaining our attack and demonstrating how it's done and how to run the simulation with it, and the effects of this attack. We will have a few assumptions before we start. We assume that we have root access to the device using ADA, and we will assume that um, they will be running the same version as our version. Okay, so in order to start, we have to set up some stuff. We need to know what we're dealing with. So we go to ADE Home. We see we have a bunch of files that we deal with. Well, we have the basic Autoware and data. These other files are our own files that we had downloaded online. This is the PCAP that will help us replay the simulation, and this is going to be this is going to be a file that we use in our attack. So we go to Autoware in order to start. And we paste this command. This says that we need to start ADE, and we need to check for any updates. And after we check an update, we start, and then we enter ADE. So we start. Everything works perfectly, and we see that we are in ADE. Next, we want to replay the attack on a loop. So UDP replay on repeat, play it once, and we'll give it this file. So it will be running it over and over again, so we don't have to manually start it every time. Next, we open a new terminal. We go to ADE again. We do ADE, enter. Now that we are in ADE, we need to tell it that we have a source, which is found in this file. Enter. Okay, so we're using this source. And we'll tell it to run the front LiDAR sensor. So ROS2, we run the Veldine nodes, get from the cloud nodes. Some more commands. So the model is it's the V Lexus P16 remap front LiDAR. Our parameters are found in this file, and we press enter. Perfect. Now it's running. We do the same thing for the rear LiDAR. So again, we do ADE, enter. We tell it that our source is in this file. And you run ROS2 again, but this time we will use the rear LiDAR configuration. Perfect. Then we need to publish our robot state. So we enter ADE again. ADE, enter. Tell it that our source is from the setup.bash. We tell it to run. So this is all well and done. We open another terminal. Now we want to launch the visualization. So we do ADE enter. Perfect. Again, we tell it that the source is from setup.bash. And we will be using RVI Z2, that's with Autoware, and we will be running it. Perfect. So as we can see that nothing is showing, but in fact, the simulation is running. What we're lacking is sensory calibration data. So in order to do that, we open a new terminal. Well, the perception nodes are in ADE, so we do ADE enter. Again, we use the source. Then we run this command. Let's get to it, because this is very important. We see ROS run, because that's our program that we're going to use. We run point cloud transform. All right. Remap, all good. Now, here's important because we need to remap the sensors for the LiDAR front. So our parameters are going to be from a file opt/autoware/share/point cloud filter transform nodes /param/VLP16 simulation of the Lexus filter transform .param.yml. So this file is what we need to check out and see how we can attack. Then it goes on with other flags. So we run. And we go back to our sensor and we see that, oh, we're seeing some stuff. Something is happening. The sensors are working, everything looks right. All right. Let's continue on with the perception nodes. Well, now we need to find the ground because, well, how does this car know where's the ground? So we do AD enter. And we tell it that the source is the setup.bash. Here, we tell that the ray ground classifier node is found in ray classifier node parameters Lexus PCAP param YMA L. We do that. We go back to our file. Basically, we have two files running. One saying what is ground, so the green is ground. White is not ground. The car will try to avoid bumping into anything white and will follow anything green. Perfect. For other perception nodes, we won't be using them because it will slow down the computer and it will blur out the simulation. All right. Now to actually simulate the attack. We have created a file ADE called test.ymal. Sorry about that. My recording software stopped. So we will run the same command, and we will use our test file. And you see that everything's running smoothly as before. Nothing has changed. So what we will do is we will stop this. We will change the test file, and all we will do is go to the Y translation, add a 1. So this means that the Y axis will be transformed to -10. Let's run the simulation again, the test function. And as we can see, the car now thinks that we transformed the car to be on the other lane. And in this way, the system still thinks that everything's legit, everything's valid. So with this use of the sensors, because this is a replay, it's not live. If this was live, this car will see, oh, I'm nearing buildings, I'm nearing other objects, I will swerve to the right. Which if we freeze, we will see that going to the right will make the car think it's in the legit lane. But in actuality, using the other transformation, we see that the car will turn absolutely towards the buildings, and this will cause a car crash. So this is our attack. We will replay it here. And we trick the system to think the car is in a different place than it actually is. So it's an integrity attack.